Hi guys, I hope you all are doing well. So today in this video we'll be starting with our eighth and the last chapter of class ninth mathematics, that is predicting what comes next, exploring sequences and progressions. So I hope you have understood the last chapter that we have seen in the last video, that was the introduction to probability. So I hope you all have understood the concepts. So today we'll be starting with our last chapter, and here our journey ends for class ninth mathematics. So today's chapter is exploring sequences and progressions. So basically we'll be focusing on sequences and progressions and further discussing the concept of arithmetic and geometric progression. You'll be also getting this chapter, the arithmetic progression, in your class 10. That would be your chapter 5th of class 10th mathematics, chapter 5 of class 10 mathematics. So yeah, today we'll start with this chapter. I have noticed one thing, that class 9 syllabus is bit harder than class 10, but that's okay. Uh, you all have only the base concepts, so you do not need to worry. So, okay, let's get started with this video, with this chapter. Introduction to sequences. So basically, we see patterns around us everywhere in nature, in art and music and finance, and so as we see in mathematics, as in numbers. Okay. So there are many sequences. Let's say a very basic example of sequence is a natural number sequence. So natural numbers start with one, okay, and it goes till infinity. So if you see that there is a sequence that has been found, 1, 2, 3, 4, 5, 6, 7, etc. Okay. Then we have odd numbers, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19 till infinity. Then we have triangular numbers, that is 1, 3, 6, 10, 6, 10. If you don't know what are triangular numbers, we can say that, let's say I have 1, okay, 1, then uh, if I add these numbers, I get 3. So 1, 2, 3. Then 1, 2, 3, 4. So 1 plus 2 plus, no, wait. Yeah, so my bad, my bad. So now it is, there are 6 numbers. Then I again write, if I put 1, 1, 1, 1. So I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, sum of this is 1, then sum of this is 3, then this 6, then it is 10, and so on and so forth. Okay. Then we have square numbers. So if I square each number, 1 ka square is 1, then 2 ka square is 4, then 3 ka square is 9, 4 ka square is 16, and so on till infinity. So basically, these numbers form a sequence. Okay. So how can we define a sequence? Let us define sequence as an ordered list of numbers where each number is a term of the sequence. So let's say for a natural number, 1, 2, 3, 4, every number, each number is a term. This is a term, this is a term, this is a term, this is the term. So if we see the sequence, this is the first term. So this is T1, or you can say that S1, or you can say that A1 also. T1, S1, this is the second term. So it is represented at T2, then 3 is T3, 4 is T4, anything we can say it as. Okay. So if you notice something, these the sequences are formed with some of the with some coordination and some connection between them. So if you see 1, 2, 3, 4, 5, there is some connection between them. That the difference between the any two consecutive numbers is always one. We can say one it as in like that. Or else I can say 1, 2, 4. You can say it as they are they one thing that common in between them is they are square of that they are squares, right? Sorry, 1, 4, 6, 9. So they are commons of these numbers. They are squares of these numbers. Okay. So this is how we say it as a sequence. We can also say sequence as the sequence of even numbers 2, 4, 6, 8, 10, 12, 10, 12, etc. etc. Okay, I hope that's understood. So this is how we define a sequence. Now we have an explicit rule for a sequence using the notations Tn. Tn or Sn or Un, we can write an explicit rule for the term in n position of sequence, that is the n term, and explicit term formula uses the term's position number n to calculate its value. So basically, we write the sequence in terms of n so that if we start putting the values of n in it consecutively, we get a sequence. Okay. So if I say I have a sequence un is equal to 2n minus 1. So if I put 1 in this sequence, I get u1 is equal to, if I put n 2 ones are 1 minus 1, that is 1. Okay. Similarly, if I put 2, I get 4 minus 1 3. If I put 3, I get 2 3s are 6 minus 1, that is 5. Observing these numbers, we can say that this is a sequence of all the odd numbers 1, 3, 5, 7, 9, 11. This is what it is given in this example. That is, un is equal to 2n minus 1 is the explicit rule for the nth term of the sequence of odd numbers. Similarly, we can say that un is equal to 2n is the sequence explicit rule for the nth term of sequence of even numbers. If you put 1, you get 2. If you put 2, you get 4. If you put 3, you get 6, and so on and so forth. So this is how we define the explicit rule for the nth term of a sequence. We can get any sequence for depending on the explicit rule. So you can refer this sequence also. So to find the what is the 100th term, we need to put n is equal to 100. As we put in n is equal to 100, I'll get 500s are 500 minus 2, that is 498. It must be somewhere over here. Okay, so this is how we use the explicit rule for the nth term of a sequence. Okay. Then there's a rule called as recursive rule for a sequence. Okay. So if you consider a sequence 1, 4, 7, 10, 13, the nth term is Tn 3n minus 2. If you put values of n from 1 to infinity, you get this sequence. Okay. So note that the term is 3 more than its previous term. So you can see that the term is 3 more than the previous term. So basically we can say that the difference between any two consecutive numbers here is any two consecutive terms, to say it explicitly, we get the difference 3. So this is how we can say that the n can take values from 2 to 4, 2, 3, 4 to infinity. So this way of describing a sequence by relating terms to previous terms is known as recursive rule or recursive formula. So basically, I am relating the a number v- using its previous number. Basically, I can say that 10 is written as 7 plus 3. So I am using the previous term of that particular number, right? So this is what we call it as recursive rule or recursive formula. I hope that is clear. Then we have a Fibonacci, then we have a special series called as Fibonacci series. So Fibonacci series is a series that we get by adding the previous two numbers. So firstly, I'll get 1, okay? I get 1. To get the second number, I need to add the previous two numbers. Here we have no numbers, so let us take it at 0. So 0 plus 1, I get 2. Now again, I'll add these two numbers, I'll get 3. If I add all these numbers, 1 plus 2 plus, if I add the previous two numbers, I get 5. Then again, previous two numbers, 3 plus 5, I get 8. Then again, 5 plus 8, 13, and so on till infinity. This is called as the Fibonacci series, where we get the next term by adding the previous two terms. Okay, cool. So next up we have exercise 8.1 that you can do it on your own. Moving further, we have to understand the concept of arithmetic progression. So here, arithmetic progression is a special kind of series wherein we get the next term, wherein the difference between any two consecutive numbers is same, or else we can say it as we get the next term by adding a fixed number to the previous term. Every term, to get any term, to get a term, we add a fixed constant number to the previous term, and then we get the next term. For example, if I say a sequence of even numbers 2, 4, 6, 8, 10, 12, up to infinity, we can see that if I add 2 plus 2 to 2, then I get 4. If I add 2 to 4, then I get 6. If I again add 2 to 6, I get 8. If I add 2 to 8, I get 10. So this is what we call as arithmetic progression, where a constant number is added to the previous term to get this next term. I hope that is clear. So yeah, this is how we can define arithmetic progression. So here we got one example. I can take any example. Let's say 1, 3, 5, 7, 9. Now you see again we are adding 2. Okay, we'll take another example. Let's say we are taking an example of I'll say okay, 2, 5, 8, 11, 14. Now you can see that as we add 3 to each previous term, we get the next term. Okay, so this is how we say that we call we what we call it as arithmetic progression. So in general, we can write arithmetic progression as A plus D, A plus 2D. Okay. So we can say that A is the first term. A is defined as first term. Then D is known as the common difference, because we can see that the difference between each term pair is same. It is constant. You can see that if we subtract this also, I get a difference of D. Here also D. ठीक है. So this is how we generalize arithmetic progression. ठीक है. So let's say that if we have 1, 3, 5, 7, 9. Okay, how will we get D? The value of D is we can take any two consecutive terms and then subtract the previous term from its next term. ठीक है. Here we can say that 3 minus 1 is equal to 2. So therefore 2 is the common difference, and here A is 1, right? Because that is the first term. ठीक है. And also we need to learn that the general formula to represent the nth term is A plus n minus 1d. This is how we represent nth term. uh, I hope that is understood. You need to know this much only for as far as arithmetic progression is concerned over here. Then as we visualize AP, we get this type of a graph. Okay, if we put the values of A and D or any in general. Okay. Next up, we have some of the first n natural numbers. There is a formula for to calculate the sum of arithmetic progressions, but I think you do not need to know that formula. You just need to understand the sum of the first of n natural numbers, that is given as sum is equal to n plus 1 by 2. Here you can put n. If I have been given that calculate the sum of first 100 natural numbers, then I can say that S 100 is equal to 100 plus 101 upon 2, 50, and whatever, do the math and get your answer. 5050 would be the answer, I guess. Okay, cool. So, yeah. Mhm. Okay. Next up, we have exercise solve. Next up, we have geometric progressions. Geometric progressions basically we it is also a special kind of sequence in which when we get the next term by multiplying a constant number to the previous term. Every term each term is derived by multiplying a constant number to the previous term. As we saw in GP, we used to we saw in AP, that is arithmetic progression. We used to add one number. Here we multiply a constant number to the previous term and get the next number. So if we get 3, 6, 12, okay. If I multiply 3 with 2, I get 6. And if I multiply 6 with 2, I get 12. If I multiply 24 with 2, I get 14. So this is what a GP is. That is the geometric progression. We have a common multiplier, also known as the common ratio. Here 2 was the common multiplier or the common ratio, that is denoted by R. As we saw a general form of AP, we also have a general form of GP, that is given as A R AR square, AR cube, and so on. Yeah, right. And it goes till AR an minus 1. So, and n is the number of terms. Here, a is again the first term. Okay. R is the common ratio, common ratio, and nth term is represented as ARn minus 1. Okay. This is what you just need to know about GP. Again, next up we have solved examples, etc. This is the self-learning part. You can do it. You can just read it and get hands on it. And in this chapter, that much is only given. You have a topic that visualizing a GP. If you plot a GP, that is geometric progression, this is what your graph looks like. It is a sort of a parabola. Uh, yeah. So yes, we are done with the chapter that was the exploring progressions and sequences. It is a very basic and simple chapter. You will again learn it in your class 10. So this much only you need to know about it in this video. I'm making this video a bit short because it is the last chapter also. Last chapter, and also the thing is, uh, you do not you are not required to do so many. You do not need to go in so much of depth for this chapter. हल्के से ऊपर ऊपर से दिया है. Only simple terms are given in form of n and n. If you put values of n, you get your answer. No need to worry. If you have any doubts, you can definitely put it in the comment section, and I'll get back to you. Uh, and I'll get back to you. Okay. So here we have a short summary that the sequence is an ordered list of numbers. Then we have a general formula to write a sequence, and an explicit formula to know the n to know the value of nth term. Then we have recursive formula that gives the value of given term using the values of previous term. Then we have a triangular number sequence that is also represented as Tn n plus 1 by 2. Then that is sum of natural numbers. Then we have arithmetic progression. We learned about common difference, first term, nth term of arithmetic progression. Then we learned about nth term of geometric progression, common general formula for geometric progression, common ratio, and then we saw the attributes of fractals that you will see. That is not a problem. And that's it for this chapter. I think we are done with this chapter, and we'll also do follow subscribe to my channel. Here we end our class 9th mathematics, but I have also uh, a playlist for class 10th mathematics also. You may refer that too. And I also have a playlist of class 9 science also. For as of now, there is only one video on the playlist. In the upcoming days, we'll also cover the full syllabus of class 9, that is from chapter 1 to whatever chapters it has. Okay. So I think we are done with this playlist. This is the last video for of this playlist. That is the last chapter of class 9th math. Eh, that was predicting what comes next, exploring sequences and progressions. So it was a very great experience to help you all. To If I have contributed something to your learning, please let me know. And I had fun doing this playlist. It was great doing class 9th maths playlist. So yeah, that's it for the for today's video. I think I'm done with this chapter, and we are done with the whole syllabus of class 9 mathematics. Congratulations on that too. All the best for your exams, whatever exams you give, 9th, 10th, 11th, 12th, etc. If you need any help, any guidance, feel free to reach out to me. You can put it in the comment section also, and maybe I'll just drop in my email ID in the description of this video. So please, if you need any assistance or guidance, you can reach out to me. I'm there to help you all. I think that's it for the lecture, and that's it for the syllabus of class 9 maths. I hope to see you all again in some other playlist. I'll definitely see in the ninth science playlist. Thank you so much for watching this video. All the best. Practice well. Take care and bye bye. Have a good day.
वीडियोस बनाने हैं, फिल्मोरा है ना।